Computer Science, May, June 2020, O levels, paper 1-2. So let us start. All right. Von Neumann model for a computer system has a central CPU unit, CPU, central processing unit, that makes use of registers. Identify 3 registers that may be used. As we know that there are about 5 registers that we have. We have MAR, MDR, we have PC, we have CIR, we have accumulator. Okay. The CPU is responsible for processing instructions. One stage of processing instruction is the decode stage. Identify 2 other stages of processing instructions. So as we know that we have got fetch, decode, execute. So they have mentioned decode. Now we have to tell about fetch and execute. So fetch and execute. Okay, identify the component of the CPU that is responsible for decoding. Decodation and execution is the responsibility of CIR, but since they have asked for the component of the CPU, not the register, we will definitely write control unit. Question number 2, both an interpreter and a compiler can be used when writing a program in a high-level language. Explain why programmer would make use of both an interpreter and the compiler. All right, programmer will use to translate high-level language into binary form or machine form. To translate high-level language into machine code. Interpreter will be used. Okay, first you need to understand this question. They are actually asking why the both are being used at the same time while we are making a program. When we are coding, why do we use both of them? All of you who would have an idea of Visual Basic or any other language in which the IDE, the integrated development environment, help us to basically edit as well as compile as well as to run the code. So what is basically happening that when we write the code, we write one single statement or instruction. As soon as we enter, that instruction will be in the background checked by the interpreter then and there on the go. This is called dynamic syntax check. So as soon as we write an instruction and enter, that instruction gets checked right away. And if there are any discrepancies, that one particular instruction will be actually marked. There are any syntax errors or something. All right. So interpreter will be used while writing the program code. Once we complete the program code, then we use the compiler to create an executable file. Okay. Compiler will generate executable file as soon as the program is completed. All right. So Interpreter helps to debug dynamically. Okay. Compiler, basically, I think that's it. You don't need to write a lot. So when we are writing the program, and if there are any syntax errors, compiler will check it dynamically and will tell us about that particular mistake that we have committed. And this is basically debugging on the go. Once your program is completed, that program will be executed using the compiler's generated executable file. All right. Now, give 3 reasons why a programmer would choose to write a program in a high-level language instead of low-level language. High-level languages are easier to understand and remember. High-level languages are easier to find bugs in them, debugging. They are machine independent. Independent means it is not necessary, unlike assembly language, which is just made for that one type of processors. If you write the code for one type of processor, and if you try to run it over another computer, another processor family, they won't work. This high-level language, on the other hand, is basically independent, means that you can write a Pascal code for Mac, maybe for Windows, maybe for Android. It works everywhere. So they are high-level languages. They are machine independent, and or you may call it portable. Okay. High-level languages mostly have a software called integrated development environment, or IDE. High-level languages mostly have IDE that help to code, debug, maintain, and manage program in one area. Okay. And you may write, there are many high-level languages out of which you can choose any. All right, so do you get it? It is easier to debug. This is just 3 marks. You can write any 3. It is easier to understand and remember because it is English like. Easier to find bugs. Debugging is easier. They are machine independent, portable. You don't have to write one language all over. You actually have to have one single code that you can run on any machine. Okay, so there are so many high-level languages out of which you can choose any. They all are easy to understand. If you write a code for one machine, you can write it. You can use the same code for different platforms. They are portable, machine independent. If you take the same code for another processor, you will compile it for that particular processor. That same code will work for that processor as well. Okay, and there is a software which is called integrated development environment, in which you can edit, write, debug, compile, maintain, run, whatever. You can do anything with it. Okay? So these facilities are not available with assembly language or low-level languages. Now, a company collects and stores data about its customers. The data is stored on a server in the company's office. The data is transmitted to cloud storage to create a backup. You know what cloud is? Google Drive, OneDrive, these are Dropbox, they all are clouds. Cloud is the server which after the subscription allow you to put your file there. So they are always in the server, over the cloud, in the internet, and whenever you like, you can access them. We all are habitual with it. So cloud is something very common nowadays. The data is encrypted using symmetric encryption before it is sent to the cloud. Describe how data is encrypted. Now, basically, this question is related to encryption algorithm, which is symmetric. Okay, symmetric means that both the client and the server are using one single key. All right, and I told you in the other class that whenever they ask for any mechanism that is based on the software, the first line of code that you write is it uses an algorithm. So we'll start that way. Encryption will use an algorithm. Okay. An encryption key which is basically a session key will be used. Plain text will be encrypted using encryption key it will generate cipher text. Okay, it will generate cipher text. Same encryption key or session key will be used by sender and receiver, in this case user and cloud, to encrypt and decrypt. All right, so this is what you were to write here. So encryption, describe how data is encrypted. Encryption key will use an algorithm, or you can write symmetric encryption. This is the name of algorithm, symmetric encryption. An encryption key, session key will be used. Plain text will be converted using encryption key into ciphertext. Same encryption key or session key will be used by sender and receiver. In this case, these are user, which are us, and the cloud to encrypt and decrypt. All right. Give 3 other methods that can be used to secure the data in the office. So there are several methods that we basically have studied. Those were basically, this is in terms of security with respect to unauthorized access. Okay, so username, and password. If you do remember, I taught you about access rights. Let's revise what access rights are. Whenever someone subscribe or get a job in an organization, or they take admission in a school, they are assigned a username and password, and against that username and password they have certain access rights. They can only access to their own data, and they cannot access the data which is not for them. For example, when we actually log into our email IDs, we only can see emails which are meant for us, but server would have the same database for thousands and millions or maybe billions of the users, and all the emails will be in the same database, but we can only access those which are written in favor of us against the username and password that we have. So these are called access rights. Yes, Rayan, biometrics can be used, but this is with respect to internet. So biometric is when we are actually accessing physically, all right, in front of computer. Like I am in front of this computer at the moment, but what if I am sitting somewhere else and my computer is somewhere else? So access rights, firewalls, encryption, and especially asymmetric encryption. Because they have said other. This is basically symmetric encryption. All right, so in other way, we have to write asymmetric encryption. Okay, so that becomes anti-hacking software is firewall. Yes, yes. Okay, and that's it. I believe we had to write 3. So we had written 4 firewalls. And yes, we have another type of firewall, which is called proxy server. Proxy server. Okay, so we can write that as well. So they said 3 other. Other means which is not this one. Okay. All right, identify the name and draw the single logic gate that can replace this given logic circuit. So this is basically NAND gate that can replace this. Okay, this can be replaced by NOR gate, not OR gate. So basically we are combining these two. Okay, so once you combine, you basically get this. Okay, complete the truth table for this. So A or C is basically A plus C, and not A means A naught, and not C means AC. And remember, A naught, B naught is not equal to AB whole naught. Always remember that. Okay, so do not get deceived by the idea. Exclusive or B. So they all are equal to. So this is mathematical model. This is logical expression, or what do we call it? Logic expression. Okay. Now let us start A plus C. A plus C means we have to look into A and C, and if there is only one, we can write 1. Then we have to have A naught and C naught. So A naught is 1, 1, 1, 1, 0, 0, 0, 0. C naught is 1, 0, 1, 0, 1, 0, 1, 0. And then we have A naught and C naught. So 1, 0, 1, 0, 0, 0, 0, 0. And then we have A plus C and A naught C naught. A plus C and A naught C naught. 0 means these two. 0, 0, 0, 0, 0, 0, 0, 0. Okay. And then we have what? Exclusive or B. So now this result will be exclusive or with B. Whenever there are same inputs, the result will be 0. So 0, 0, 1, 1, 0, 0, 1, 1. So this is your answer. 0, 0, 1, 1, 0, 0, 1, 1. This is your answer. Okay. Give 3 functions of a browser. Browser does many things. So it basically interprets HTML. It renders web pages. Checks HTTPS status for security. It checks if the website is secure or not. It uses ISP's DNS to find IP addresses. Fetches web pages from server. Stores history. stores bookmarks. Remember, if you write history or bookmark, you will only get 1 mark. Okay, so favorites, history, bookmark, they all will have just one single mark. And then it has tabs for different web pages. So you can see so many websites using so many tabs. Okay. All right.